Hi, hello everybody. So this is the second video here dealing with creating circuits in Logisim. So this is possibly the second part of the first video where I'm going to show you how to get more information out of your circuit in terms of Boolean algebra. So after the circuit is created, so this is where we stopped last time, you can go back up here and then click on Analyze Circuit. When you do that, this is going to show you more information about the circuit you just created. And you get an output like this one. So you have here the truth table, which is very, very useful for analyzing your circuit, because even before creating a circuit, you could come up with the truth table. And these are the output bits that you want for your output queue. Right, so just checking, for example, for the last case where all bits are 1, right? So at the OR, I am going to be passing a 1. So let's just move everything to 1. So I'm passing 1 to OR, and C is inverted to an off, 0, and then the 1 and 0 should be 0. So here's my output 0. So this is very useful in case you want to see if your circuit really works. Obviously, you can test it, and you should test it, but this is how you get the truth table. You have a tab for outputs, Q. There's only one output here. There are the inputs. This is the expression that we are using. Just understand that this doesn't quite look like the expression that we have here. We have A or B and not C, but Logisim already simplifies it for you. So it distributed the not C into A not C or B not C, and it creates that circuit for us. And here's the minimized circuit using the Kmap approach. So this is pretty useful, okay? And it shows even your groups and the minimization that we normally would get using the Kmap approach. Okay, so in the event that you do want to see this, you can always go on the project, analyze circuit, but you should get into the habit of testing your circuit. So to test your circuit, you would click on this hand and then flip the bits from 0 to 1 and see what the output is. Okay, so I hope this is enough for our purposes, how to create the circuit and how to analyze the circuit afterwards.